Hi, my name is Dylan and welcome to my video about what is DevOps. So let's start with the definition. DevOps combines development or dev and operations ops to unite people, processes, and technologies in application planning, development, delivery, and operations. DevOps enables coordination and collaboration between formerly siloed roles like development, IT operations, quality engineering, and security. Teams adopt DevOps culture, practices, and tools to increase their confidence in the applications they build, respond better to customer needs, and achieve business goals faster. DevOps helps teams continually provide value to customers by producing better and more reliable products. So, this definition is the one that you'll find on the Microsoft website, and it's kind of like the most common definition for DevOps. Okay, so what about in reality? What outside of the nice definition? DevOps has become an engineering team. So that team focuses on enabling software development teams to providing automation in the form of continuous integration and continuous delivery, also known as CI/CD. They work a lot with creating infrastructure as code to help with the automation of deployment of infrastructure. And unfortunately, this means that the team tends to manage a lot of things and it can become a bottleneck. And this is kind of against those core ideas that we mentioned in the definition about DevOps being a culture. By kind of condensing that culture into one team and then just putting all these people into this one team, it becomes very difficult for them to scale, and that starts to cause some problems. So let's go over some of the parts here. We're not going to cover everything about DevOps in this video. This is very much more of an introduction to DevOps and some high-level features. But what I did want to go over first is what is CI/CD, or continuous integration and continuous delivery, also sometimes called continual delivery. So continuous integration and continuous delivery is the process where the building and deployment of software has been automated. This is usually done on a platform such as GitHub, where the source code is stored as well. When changes are made to the source code, a CI/CD pipeline is started, which includes a set of steps to build and deploy that application. So what I want to do now is actually go and show you an example of a CI/CD pipeline so we can kind of step through its different steps and show you what the goal of it is. Okay, so let's now have a look at some CI/CD pipelines, specifically using GitHub and GitHub Actions. So I have these two pipelines here. So I'll go through this one build first. And what this pipeline is doing is it's building an application. So we have a basic .NET application here, just a demo application. And what we're doing here is that we're running a pipeline called build. This is triggered when code is pushed to our source control. And then what it does is it first checks out the code, so it downloads the code into the runner. So the runner is the actual service which is going to be building our code. So we download the code to it. We then set up .NET. So we actually use this action here called setup.net, and we tell it what version of .NET we want to ensure that it has on the agent. We then install our .NET dependencies. So this is part of the .NET compiler. It will actually pull down all the dependencies for the application, and then we call .NET build. So what we're doing here is we're not actually building to publish or anything like that. We're building to check. So we're saying, okay, make sure my application builds with no errors. And this is really good when you've got lots of team members pushing code in. They may be working on separate branches within the Git repository, and they just want to check, is the changes that I'm pushing into my branch breaking the build, or are they okay? Then what we have is a second pipeline called build and deploy. And what this pipeline is doing is it's building the application, and specifically building it using Docker, which is not something I'll cover today, but I will do a video on Docker files, and how we use them. But for now, just all we need to know is that a Docker file creates a Docker container, and that container is then has our application inside and running inside that. So what we do here is we say on push again, and this time we're telling it only to trigger on pushes to the branch main. So this is our main branch within our repository, so we don't want this to trigger when people are acting on their own branches, only when things have been pushed into the main branch. A lot of these things are called branching strategies, so I'll cover that again in another video. Just for now, we just need to worry about the main branch. So what I have here is a couple environment variables. So there's a registry and an image name. Registry is where I'm going to be pushing the final built container to, and the image name I'm just naming the same as the GitHub repository. So we come into the steps now, and I see I need a couple of permissions. So these are permissions to allow me to read information about my GitHub repository and write to the packages. So that's where we'll be storing the Docker container when it's built. And again, as the first example, we use actions to check out the code to the runner. We then log into the container registry. So this is the GitHub hosted container registry. We then do a metadata action to extract metadata from this environment to create the image name and image registry information. And then we push, or build and push. So this does the actual Docker build action. So that'll build our application and then push it through to the container registry, and it uses that metadata that we collected to create the tags. So again, if you're not following what all that's about, that's okay. I will be covering that in a further video. But we can see here that with these CI/CD pipelines, where the first one is just CI, so continuous integration, where we're checking to make sure that our builds are all going to pass, and we're not going to try and merge in broken builds to our main branch. And our build and deploy is actually doing the steps to build our Docker container for our Docker file, and then push that into a repository, which will be then ready to deploy either to another service, or if we're building a system that other people are deploying, they will then be able to grab that version of the image from the container registry. Okay, now we've seen an example of CI/CD. It makes sense to start talking about infrastructure as code. So infrastructure code, or IAC, refers to storing the state of the environment, usually a cloud environment, in code. So we do this to allow for the automation of deployment, as well as to make it easier to manage infrastructure at scale. There are a few different kind of languages to writing IAC, but today I'll show you two that I use the most, and that's Terraform and Bicep. So let's jump into another demo, and I'll actually show you what these two languages look like and what we're kind of doing when we're using infrastructure as code. Okay, so now let's look at some infrastructure as code. So back to our example application, I have a folder here called infrastructure, and I have two folders here which represent the two different languages for infrastructure as code that I'm going to show you today. So we'll first look at Terraform. So Terraform is kind of a cloud agnostic way of doing infrastructure as code, so you can use Terraform across multiple clouds. It means you only really have to learn one language, but it does mean that you have to kind of wait for things like what we call providers that actually give you access to the different cloud components to be updated. So it can be behind at times, but it is pretty widely used, especially in organizations that might have more than one cloud kind of present within an environment. So what we'll do, we'll look at the TF files here. So we have the first one, which is our terraform.tf file. So what this does is this sets up our providers. So in this case, we're using the Azure provider. And then it also sets a required version for Terraform to make sure that your Terraform application on your machine or on your runner is at the correct version. So then we have our main TF file. So in here, we again reference our provider and any kind of features that we might need to enable on that provider. And then I have a module here. So this module gives us the directory to the module and sets a set of parameters from these var objects. So these var objects or variables are defined within our variables.tf file. So you can see here I've got a set of variables, so an app service plan name, resource group, location, and an app name. And these are all types of string, and I've got a description here of what each of these do. So then once we've gone, so we do get those variables into here and we send them to this module. So a module is a way of kind of encapsulating a object or a service within Terraform. So in this case, open the modules, I have one called app service, and it also has a main TF, a variables TF, and an output TF. So in the variables, and we'll see the same variables that we used in our base variables. And then in the main, we now have the resources which we're actually defining. So in this case, we're doing an app service plan and then a Linux-based web app. So this is using app service in Azure. And then it's taking those variables to deploy those resources. And the outputs TF allows us to return something when we run this code. So in this case, I'm returning what the default site host name is for the web app, as well as the ID of the service plan. And then that'll come back and be able to be used again within the main.tf file. So one of the other important things to understand with Terraform is that when you're deploying Terraform, it needs somewhere to store what's called a state file. And this state file manages the representation of what is in your environment. So when you do things such as you run a Terraform plan, which is a function of Terraform to ask it to assess what is going to change if you were to run this Terraform code, it will use that state file to actually generate that plan. So that can sometimes cause some complications when you've got a state file which, say, a lot of people are using it, might lock the file when it's in use, or someone might add something into the environment manually, and in that case it won't exist in the state file, and you'll need to have that added in kind of after the fact. So I will go further in detail in Terraform in a later video, so this is just kind of a very high level of it at the moment. So now let's move to Bicep. So in Bicep, so I have a main.bicep file, and this defines again some parameters. So similar to Terraform where we're using parameters here. And then I have a module which is called app service, and I've defined that module here. Now, Bicep is specifically just for Azure, so it's not as flexible as Terraform in the way that you could have it across multiple clouds. This is very specific to Azure, and under the hood, what this is doing is creating what we call ARM templates, or Azure Resource Manager templates. But this is an abstraction to make it easier to work with those rather than trying to deal with those templates because they're very verbose. So in here, I've got a name for the module. So this will actually appear in Azure as the deployment name when it's running. And then it has two parameters, so an app service and a repository URL. So again, similar to Terraform where you can have the variables, we have a parameter file. And this we can say it's related to the main.bicep file. And then we have the parameter values for our app service name and our repository URL here as well. Then we go into the module and we have this app service.bicep. Again, very similar to the main one where we have parameters set here at the top. So these are values that are either set, so these have default values, or they can be overridden by providing these parameters. The ones without values are required, so if you don't supply them, then when you try and run the bicep, it'll fail. And then we have two here which are variables, so these are being used to create from further information a variable containing, so in this case, the app service plan name, which we're using the app service name, adding a dash plan on the end, and enforcing that it's all lowercase. And with the source control name, again, we're doing something similar. We're using app service name and putting /web at the end. So now we define our resources. So again, with the app service plan, we use this string here to identify what version of the API we're talking to. So Bicep talks directly to the API, not requiring a provider. And then we fill in the parameters for that specific API endpoint. So we have a location, we have some properties, a SKU, things like that. And then similar again, the app service, we're defining that here. We're using the ID of the app service plan here. So you can call it and then just call it .id. And then again, the source control here, which then integrates with it as well. So that's the two kind of main infrastructure as code languages that I specifically use. And majority going forward, I tend to do Bicep because I do focus on Microsoft technologies. So I pretty heavily use Azure. But as I said, I'll do some more deep dives on both Bicep and Terraform at a later stage. So, in summary, what we've looked at today is a very high level of DevOps. So we're focused on the automation component of DevOps, spoken a bit how it's a fusion of development and operations. It was not intended to be an engineering team, but more of a culture. And I just noticed a typo. I'm going to go fix that. Yeah. Let me go fix that quickly, and we can take that again. So that's how I spell culture. Okay. Take that again. All right. So in summary, what we've seen today is a very high level about DevOps, focusing on two of the main tasks. So first of all, this is automation, both in the CI/CD and also within deployment of infrastructure as code. So we've seen that it's a fusion of development and operations, and it was not actually intended to be an engineering team, but rather more of a culture spread across a group of engineering teams. It is very heavily tied to the usage of the cloud, and a lot of time when people are talking about DevOps, they also mean cloud engineering. So for this video, we'll just scratch the surface. I will be doing a few more videos in the coming weeks around more in-depth discussions on DevOps, and we'll also look into things such as platform engineering and where that fits within the evolution of DevOps itself, which will cover a much more in-depth look at what the day-to-day work of a platform engineer is. So I hope you found this video useful, and as always, please like, share the video if you would like, and feel free to subscribe. That would be great. And I'll see you all in the next video.